Now let us start with the exercise. Question number 1 is that log of 6 plus log of 5 is expressed as option A is log 11, option B is log 30, C is log 5 by 6, D is none of these. Now we have the log property that log of m to the base a plus log of n to the base a is equal to log of m into n to the base a, which states that if we take log of m and n separately with the same base a and add them, then it is equal to log of the product of m and n to the same base, which is a. So with this rule, if I am to write for m 6 and n as 5, I get log of 6 plus log of 5 is equal to log of 6 into 5. 6 and 5 will be multiplied. Here base is not given, so we assume that the base is 10. It is common logarithm. So this becomes log 30. 6 and into 5 is 30. So our option B is correct, log 30. Now we see question number 2. Question number 2 is that log of 8 to the base 2 is equal to. Options given are 2, 8, 3, none of these. Now we are to find log of 8 to the base 2. Now the definition of log, we know that log of m to the base a is equal to x, then a raised to the power x is equal to m is the definition. Definition of log is that log of m to the base a. This a here is base, which becomes a here, the base of the indices. With this, if I am to calculate the value of log 8 to the base 2, I assume it as x. I take log 8 to the base 2 is x. So this implies that 2 raised to the power x is equal to 8. With the definition of log, 2 here is the base, so 2 will be base here also in the indices form. Now 8 can be written as 2 raised to the power 3. 8 is 2 raised to the power 3, and if we compare these two, on both the sides the base is 2, so powers will also be equal. So therefore x is equal to 3. X is equal to 3 means the value of log 8 to the base 2 is 3. So our option C is correct answer. Answer is that log 8 base 2 is 3. Question number 3 is that log of 32 upon 4 is equal to. Option A is log 32 upon log 4, B is log 32 minus log 4, C is 2 raised to the power 3, and D option is none of these. Now we know that log of m upon n to the base a is equal to log of m to the base a minus log of n to the base a. This we have seen in our theory that log of m upon n, if we are to find it to the base a, then log of m to the base a is subtracted with log of n to the base a. They become in the subtraction form if here they are in the division form. Now with this rule, if I am to find the value of log 32 upon 4, then this will be log of 32 minus log of 4. M here is 32, n here is 4, base is not given, base we have taken as 10. So this is log 32 minus log 4. Our option B is the correct option. Now we will see question number 4. Question number 4 is that log of 1 into 2 into 3 is equal to, option A is log 1 plus log 2 plus log 3, B is log 3, C is log 2, and D is none of these. Now we have the property of log that log of m to the base a plus log of n to the base a plus log of p to the base a, if logs of m and p with the same base as a are given separately in the addition form, then they are in the product form if we take the log of their product with the same base as a. With this rule, if I am to write 1 as m, 2 as n and 3 as p, then our required will be log of 1 plus log of 2 plus log of 3. This will be with the same base as 10. So our option A is correct. Log 1 into 2 into 3, if they are 1, 2, 3 are in the product, then their answer will be, they will be equal to log 1 plus log 2 plus log 3 in the addition form. And hence our option A is the correct answer. Now we will see question number 5. Question number 5 is log of 0.0001 to the base 0.1 is minus 4, 4, 1 by 4, none of these. Now here we are to calculate log of 0.0001 to the base 0.1. Now as we have seen in one of our previous questions, we take this as x. Let us say the required value is x. Now with the definition of log, 0.1 to raised to the power x is equal to 0.0001, because we have the rule of log of m to the base a equal to x, then this implies that a raised to the power x is equal to m. This is the definition of log. With this definition, if I am to write log 0.0001 to the base 0.1 as x, then this base will become the base of indices here. So 0.1 to the power x equal to 0.0001. Now 0.1 can be written as 1 upon 10. 0.1, if I remove point here, I am to write 1 here, then 1 digit is more, so 1 0 will be here. So 1 upon 10 to the power x is equal to, again I remove point here, I am to write 0.0001 in the fraction form. So what will I do? I write, instead of point, I write 1. 4 digits are there after decimal point, so 4 zeros will be there. In fraction form, 0.0001 can be written as 1, then 1, 2, 3, 4, 4 zeros, 10,000. Now this can be written as 10 to the power 4. This can be written as 10 to the power 4. So 1 upon left hand side is 1 upon 10 to raised to the power x. This is 10 to the power 4. Now power of 10 here is x. Power of 10 in the denominator is 4. So this gives us x is equal to 4. This gives us x is equal to 4, and hence our option B is correct, because the value of required log 0.0001 to the base 0.1, we have taken it as x. So required value is 4, because we have obtained x as 4. Option B is here correct.